This is the second chapter of the introduction to electric circuit. The topic of this chapter is the circuit elements. In this chapter, we will deal with about what is the element of electric circuit. Especially, we will introduce the resistor and the voltage source and current source. The source is divided into two groups. The first is independent source, and second is dependent source. We will deal with about these topics. First, I want to introduce about the linearity. What is the linearity? In Korean, it's 선형성. 선형성. This is a very important characteristic we will deal with about that. To check the linearity, we need to know about the two things of superposition and homogeneity. If something satisfies the property of superposition and homogeneity, then you can say that is linear. Linear is not defined in the electric circuit. The linear is a very huge concept. So the many systems can be analyzed by the linear approach. So in the most system we will deal with in the undergraduate courses would be the linear. In the case of nonlinear system, it's very complicated to solve the problems or analyze. So that will be covered in the graduate courses or rather the expert area. So fortunately, in this course, the electric models would be assumed to be the linear. They need to check about what is a linear. This is very important. The first, we need to talk about the homogeneous and superposition. I want to tell you about the superposition at first. Let's assume that we have some system. The system has an input is I. And I don't know what is that, but there's some system, the F. If it's insert to the F, then output will be come out. We define output is V. Then I don't know what is the F. I don't know what is the F. And I don't know what is the I. And what is I don't know the V. But we can check if I don't know where the belt, but I1 is inserted to F. Then we check the result is define that is V1. And we insert input is I2, another input. And we can gather another output is V2. We know about that. Then if we insert the input to the F, I1 and I2, the sum of that, then we check the output, it's V1 plus V2. Then that result is the same with that. Then you can say the F is superposition. Then the F system satisfies the superposition property. That is a characteristic of superposition. So this is a specific input and output, and another input and output. And if we insert the sum of two inputs, then the result is the same with the sum of two outputs. Then you can say this is a superposition. And we will talk about another things. There is a superposition. Another thing is homogeneity. Homogeneity is different things. And I will remember think of that. Next is homogeneity. The same example, we assume that we have input I and output is V. Then we insert input is I. Then we insert, and the input is I multiplied by the constant, the K. Then the result would be KV. This is multiplied by K. Then you can say the F satisfy the property of homogeneity. So we can summarize about that. Superposition, and just like that. This is F, this is I, and V. If I1 will be V1, I2 is V2, then I1 plus I2 makes V1 plus V2. That is a superposition. And homogeneity, with I and the system is F, then F will be V. We insert I1, then F will be V1. And if we insert KI1, then F will be KV1. Then you can say that is a homogeneity. So when the system is linear, then these superposition property and homogeneity property should be satisfied. Whatever it is, two properties satisfied, then you can say that will be linear. This is a very important characteristic we deal with about here. Okay, there's the example. Consider the element presented in the relationship between the current and voltage as here. Determine that this device is linear. You know, this is a very famous, the law is Ohm's law, right? Actually, we will deal about this equation in your high school. This is show us the characteristic of R between the viewpoint of the voltage and the current. But we will deal with it later. But anyway, I will show you that this is a system. That means we insert is R system, then we insert the current, then R is voltages. This system is V equal RI. Then we need to check this is a linear or not. So to do that, we need to check the two properties. What is that? First thing is superposition. The second thing is homogeneity. So at first we check our first things. At first the homogeneity, first superposition. Then we will guess that we insert the I1, then the output, where's that? V1 will be RI1, and we another input I2, then the result V2 will be RI2. Then if we insert I1 and I2, sum of I1 and I2, then where's that? Of V will be RI1 plus I2. This is RI1 plus RI2. There is the same with here. There is the same with here. So this is V1 and V2. So the result is here. So when you insert sum of two inputs, then output is the same with each of outputs here. Then you can say these characteristics satisfy the superposition property. Second thing is homogeneity. Then we insert the input is I. Then alpha V will be all I. Then we insert some Ki. The K is constant. Then the voltage will be all Ki. There will be written here K Ri. That is a result is K and this result. So when insert the constant multiply the input, then output will be multiplied. Then you can say this system satisfy the property of homogeneity. So this device satisfies the two things. So we can say this device is linear. It's very simple. A simple example of that. This is another example in your textbook. The second example is similar things. So let us find the element represented by the relation between the current and voltage. But I don't know what is that. Actually, you cannot define what is that. But anyway, that some device makes in these categories. Let's check this is linear or not. I will tell you again, to check this is linear or not, we need to check two things. What is that? Superposition and homogeneity. So first we'll check about the superposition. So the system is the V is I square. Then we insert some input is I1. Then the result is V1 is I1 square. And we add another input I2. Whatever, I don't know what is that, but anyway, we insert different input I2. Then the result of V2 will be I2 square. Let's guess. We add another input, but that input is sum of two inputs. I1 plus I2. Then the result will be I1 plus I2 square. Then this will be, excuse me, that will be I1 square plus I2 square plus 2 I1 I2. Then what is that? This is that V1 plus V2 and something remained I1 I2. So that is not equal to V1 and V2. So this result shows that superposition is not satisfied in this system. So superposition is not satisfied. Then next we can check the homogeneity. The same way, we adding some I1 here. Then V1 will be I1 square. And we insert the different input, but it is multiplied by constant I1, it's Ki1. Then the result will be Ki1 square. That will be K square I1 square. But this is now same with what? KV1. So that means homogeneity is now satisfied. So we can say this device is not linear. This is another the problem. Maybe you can see that this problem in the problem set in the last of the chapter 2. So this is another problem to understand, to help you to understand the what is the linearity. So this element is represented by the relation between the current voltage in this way. When you check this is linear or not, you can approach this the same way. Okay, first, yeah, we'll check it. So to do that, we need to check. The system is very simple. I don't know what is that, but it's a system. And we insert the input is I. Then output is V. But V is 6I plus 10. The first to check the superposition, you adding a first I1 inside here. Then V1 will be 6I1 plus 10. We insert the another things, another input, I2. Then the result is V2 will be 6I2 plus 10. Then we adding the I1 and I2. We insert new input is I1 plus I2. Then the result V will be 6I1 plus I2 plus 10. There will be 6I1 plus 6I2 plus 10. Then this is now same with V1 plus V2. Why? V1 is here and V2 here. That will be 6I1 plus 6I2 plus 20. So this is not different. So we can say this system is now satisfy the superposition. Therefore, this element is now linear. We can check the linearity in this way. When you want to check the linearity, we need to check the superposition and homogeneity. Next, we will deal with about the active and passive circuit element. The electric circuit has two kind of element. Actually, there are many elements in electric circuit. There's R, resistor, inductor L, and capacitor and C, and voltage source and current source and coupled inductors and whatever it is. But the all things are classified in two groups. The first is the passive element. The second is active element. A passive element is kind of this is absorb energy, and active element is supply energy. Actually, there are many electric circuit elements like the resistor. This is R, and inductor is L, There's a capacitor, and C, and some voltage source, and some current source, and dependent voltage source, and dependent the current source, and coupled inductor, something like coupled inductor or transformer. There are many things. Then this will be passive element. And this will be active element. The different things between the passive element and the active element is about that will be observed energy or supply energy. Actually, the resistor only observe energy, but the inductor and capacitor, in the case of two things, this device could observe energy and also supply energy. The inductor and capacitor absorb energy, then they store the energies, then they could supply the energy which was stored before. But the important thing is this device does not generate any real energy. These two devices store temporarily the energy. So we call this is a passive energy. But that will be the voltage source and current source. What is that? Maybe that will be the battery or generator. Including 발전기. Then this element make the energy. So this is a kind of a source in the electric circuit. We would say that will be the active element. So passive element, active element can be specified about they could supply energy and or not. But in this dialectic theory, with the R, L, C, and coupled inductor and transformer would be passive, and other thing can be understood as the active element. So passive element. And first we'll talk about the passive element. The passive element, the total energy delivered to it is always non-negative. And you mean the important thing is total energy. In the case of R always observe the energy, but L and C can be supply energy sometimes. But the energy, the LC supply is the temporarily stored energy before. They cannot generate the energy by itself. So we call this is LC and R is a passive energy. Passive element. So the passive element absorb energy. So in this case, the passive element we draw in this way. This is the element, whatever it is. Then we can define the voltage here, the V. Then current follow into the plus terminal is the current. So the important thing is the current flowing into the plus terminal. So we can draw the voltage. We define the direction of the voltage and direction of the current. In the case of passive element, we define the current to follow through the positive terminal voltage. So then power, what is that? Power is V multiplied by current. Then we define the direction of voltage and current in this way. That will be positive. That means the power is observed by these devices. So to make a direction of that way, you can say this is a passive convention. In the point of passive convention, the P is positive means power is observed. And P is negative means power is supplied. This is an important addition here. And second thing is the active element. The active element, total energy supply is always negative. That means energy is supplied from the active element to the rest element in the circuit. The active element is capable of supplying the energy. So when you draw the element of active element to here, I don't know what is that, but this is an element, active element. Then we can define this voltage in here. Then we draw the direction of the current is in this way. So current flows into the negative terminals. That means minus terminal to the positive terminal. That means plus terminals. So current flow in this way. This is arrow from the T plus in here. So to compare with the passive case, the current go into the element, but active case, current is go out from this element. And the differences. So in this case, the power is P is VI. The power is positive. That means the energy is supplied. So in this direction, when you define the current is out of the device. In this expression, we say active convention. So this was the passive convention, and this is active convention. In this case, P is positive. That means power is supplied, and P is negative. That means power is observed. So generally, when you define the passive element, we should decide the voltage direction and current direction. Yeah, in the case of passive element is R and C, L and R, we use passive convention. And when you use the battery, voltage source or current source, then we should decide the voltage direction and current direction. And in the case of that, we use the active convention here. So you don't need to confuse about that. The next is the resistors. In electric circuit, there are three basic elements. There will be R and L and C. In this semester, we will deal with about L and C, maybe chapter 7 and 8 and 9. But before that, we will deal with only R. R is very simple. So what is R? The R, to understand R, we need to know about the resistivity. The resistivity means the ability of material to resist the flow of charge. That means the resistivity define how much the current, the flow through the material. So we define is a low. That means a good conductor. I mean conductor, a good conductor. That means the current flow well through this material. That means they have good conductor has low resistivity. So this is a kind of the characteristic of materials. For example, in the silicon case, the resistivity low is 2.5 in 10 power 5. But the copper, this is very small. So copper is a very good conductor. The aluminum is quite good conductor. But in the case of silicon, is very bad conductor. Symbol of that. So we define the resistance. Resistance is a physical property of the element or device that impedes the flow of the current. So symbol of that is R. This is the symbol of resistance. So R is real things. Then the physically R is consists of in this way. This is some material. Then this is length of L, and the area was here. Then the resistivity of this material is low. Then R is calculated this way: A low L. This is very simple. Our current in charge follow this way. So when the area is large, that means there are many areas to follow the current. So area A is inverse to the R, and R means the resistivity, and these low define how much this material resists the current, and L, this is L, is as long as this L, the less will increase. So L is defined this way, and L has a very simple and basic element in the electric circuit. Electric circuit is a kind of the power delivered from the source to the load. So every element in electric circuit should define the voltage across the element and the current which will flow through the material. So the R has a very simple characteristic. We point of the voltage and current. That is Ohm's law. You already know about that. This is R, this is symbol of R. Then if the voltage here in V is a plus and minus, then current will be flow in this way, the I. We define the additional content in this way. We call that is a passive conversion. Then you can say V is IR. This is also is very basic, low in the second. This is a characteristic of the R. This is a very simple but very important characteristic of R. So from here, you can make another expression about that is, where is that? I is V over R, or R is V over I. So based on this equation, when we can check the what is current through this element and the voltage placed across the element. And here I need to talk about what is a node electric circuit. When analysis electric circuit means there will be very many elements here, like in this way, in this way, in this way, in this way, here, this way, whatever it is. But there will be very complicated the element here. when you say we know this circuit, when you say we know this circuit, we can analyze of this circuit, means we can define all voltage here. And we know all current here, 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 here. Then we can say we know this circuit. So to analyze circuit, we need to know every voltage of every element and every current of every element. So to analyze a circuit is the same thing as to check the voltage and current in every element. So we need to know about what happened in each element, the voltage and current. Now this Ohm's law shows us the characteristic of voltage and current between the R. So this is very important, and we will use this voltage current relationship between R is a basic the property to deal with the electric circuit. So this is an example of the resistor. So we need to see about that. The device is model for car battery. Maybe this is a car battery, but they'll raise 12 volts. And we adding the lamp. The lamp is a 6 ohm. Then we can model the lamp is R. This is ohm. The car battery can be modeled with 12 volts the voltage source. The problem is, let us find the current. Current is flowing through the R, and the power. Observe this, the resistor, and the energy supply by the R. So we need to have the solution. So very important characteristic of that. What is that? It's Ohm's law. So V is IR. And based on that, this VIR, V is IR, is defined this way. Here, the V, and this is I. The I is like a kind of the water. Because I follow in this way, so this current is the same with this current. And voltage is connected. The voltage, of course, the resistor is connected to the voltage source directly. So that means V is equal to the source of that. So based on that, you can calculate the voltage V is same with Vs is 12 volts. Then we know what is that the voltage is 6 ohm. Then we need to know about the current. I is R is 12 and 2 ampere. Then we can get a current here. The next is power. I already told you in the previous chapter, chapter 1, power is voltage multiplied by the current. So what is the voltage? Of course, this resistor is, what is that? 12, and current flowing through the element is 2 amps. There will be 24. There's a unit of that is watt. Next is energy. Energy supplied by the battery for 4-hour period. The energy is W is work. And it's called 0 to time, and P the time. Then based on here, this is unit of that. The unit of time is a second. So different here, and second because 4 hours, because 4 hours, so 16 minutes and 60 seconds. The P was 24 the tau. That will be, what is it? 4, 60, and 24. That will be 3.46 y unit is joule. So we can calculate the energy for 4 hours is that. Because we define the current situation over here is go through the positive value of voltage. So that means we use what? We use passive convention. So in this case, P is positive means what is that? Power is observed. So 24 watt is observed this resistor, and this energy is observed by this resistor because we define the voltage and current regulation as passive convention. Generally, resistor use passive convention. That is simple. But in the viewpoint of the source, this is current direction here, so this is here, so this is here, and this is a positive terminal of the voltage. Then the viewpoint of that, what is that? In the viewpoint of the supply, the current direction is out of from the plus terminal. This in this case, it go to the plus terminal, but in this case, go out of the plus terminal. You can say this is a active convention. So we use active convention in the case of the source. So because the current is 2 amps, it follow the same 2 amps. So in the case of that, the power, what is power? P is VI is V12 and current is 2, so 24. The unit is watt. Then we need to know these are positive values. This is 24 watt, observed by resistor. The positive value is 24 watt. What is that? 24 watt is supplied by this element. Why? This positive value and this positive value, but this is observed, but this is supplied. Why? The source use active convention. In the case of active convention, P is positive means power is supplied. You don't need to confuse about that. This is exercise 241 in the textbook. Now find this 100 ohm resistor when connected directly across the constant 10 volt source. So this is a solution. What's the meaning of that? There is some source, voltage source, 10 volts. Then there will be some resistor. How much is it? 100 ohm. Then is when it's connected directly. Then means this is connected directly this way. Then find the volt power observed by 10 ohms. Then to calculate the power, what should we do? Power is voltage and current. Then power observed, power here is P, is voltage and current. What kind of voltage? This voltage means because the power is only here, then the voltage is here. And current is also here. I make a direction of current is in this way. Why? This is a resistor, it's a passive element. So I choose the direction of here, to passive convention. Then first we need to know about current. To calculate current, we should use Ohm's law. What is Ohm's law? V is IR. So I is V over R. Then V is here this because this voltage is directly connected to the resistor, that will be the same. So V is 10 and R is 100. That means 0.1 amps. So power will be V is 10 and current is 0.1. So 1 watt. So power is positive values. Then this power is observed. Why? We define the direction of current is go to the positive terminal voltage. Then we can make this direction. Then power is positive means power is observed in here. Okay, this is another problem. This problem is placed on the last of this chapter is a problem set. The current source here, in this case, this is a current source, and the resistor is connected series in this way. Then element connected series the same current because the current is kind of the water, right? So current flowing this way. So all current flowing through this line is the same. So that means IS is equal to I. So suppose IS is 5 ampere and R is 10 ohm. Then calculate the V here. Calculate this is V. And the power observed is resistor. So you can see this. We already this problem defined the direction of the current and direction of the voltage here. So you know the current go to the positive terminal there. What is that? That is a passive convention. So what is the meaning of that? In this case, when P is positive means power is observed. Anyway, so to calculate the power, because power is voltage multiplied current, so we need to about the voltage and current. So what is the current I? Because current I is connected to the current source IS directly, so I will be IS. IS is 5 amp. Then voltage, to calculate the voltage, we should not use the Ohm's law. There is it. Then here, R was 10 ohms and current is 5, so V is 50 volts. Then power is VI. So because V is 50 and current is 5, then 250, the unit of that is watt. Because power is positive, that means this resistor observed 250 watt. Do you have any idea about how much the 250 watt is required? The huge the power. Because generally, when you say the horsepower in Korean is 마력, that means the power generated by the one horse. 1 horsepower is generally 756 watt. That means the power generated by the one horse is 756 watt. That means 250 is quite huge power. Anyway, this next problem is from the problem set in the last this chapter. So this voltage source is connected with the two resistor, but the resistor is connected in the parallel in here. Then Vs is 200 and R1 is 50 and R2 is 25 ohms. Then calculate the current here and here and the power observed in the resistor. It's a very important problem here. In this problem, they make the direction of the current and voltage. So they show us, you need to see in very, very carefully. In the problem, the current flowing through the R1 is in this way. and they go to the positive terminal. And in the case of R2, the current I2, the direction of the I2 is following not to the but from the plus terminal in this way. So we need to check. Then when you get some answer about that, we need to check the difference of that. So at first, because to know about the current, to know that, at first we use the Ohm's law. The V is IR. At first we need to check that because R1 and R2 is connected to the voltage source directly. There are nothings. They're directly connected. So V1, the addition of the here plus and minus is a plus and minus. So V1 is Vs and V2 will be Vs. It's 200, the 200. So the current is here. Then you need to check that what this Ohm's law is defined in this way. When you define this Ohm's law, this is R, then you define the direction of voltage here, then we define the current, the direction of the here is I, then V is IR. If we define this R, the direction of voltage is V, then we define the current is I. Then what is the Ohm's law? Actually, Ohm's law is defined in this condition, in this direction, and then you can say. Then, if we express the current in this way, then that value will be minus I. So in this convention, in the active convention case, the Ohm's law will be V is minus IR. They're confused, so I does not recommend you to deal with about this. So the way to solve this problem is in this way here. At first, we will calculate not I2. We calculate not I2. We define another current in here, I2 prime. Then I2 prime will be minus I2 because the same magnitude but the direction is different. Then we can calculate at first R2 because the direction of the I2 prime is a passive convention. So V2 will be R2 I2 prime. Then how much is it? The 200. R2 was 25 I2 prime. So I2 prime will be 25, 200. What is that? 8 ampere. But the problem asks the current is I2. So I2 will be minus 8 ampere. So what is I1? I1 is a passive convention, so I1 can be calculated. V1 is I1R. I1 is R is 50. The V is 200 is 4 ampere. So I1 is 4 ampere and I2 will be minus 8 ampere. Then we need to check the power observed with each resistor. And the power P is V is 200 and current is 4 is 800 watt. In the case of that, the direction of I is go to the positive terminal. So P is positive means this is observed. But in the case of that, the P is VI. V was same thing, 200, and current is minus 8. So there will be minus 1,600 watt. This minus value. So that means, is that the power 1,600 watt is generated from this? No. In this equation, the I used active convention. So that means P is negative, means the power is observed. This is another example. This is the 2, 4, and 6. So in this case, the source is a current source here. And then the resistor is connected in a series way. So because this is one path, so the current I1 is current flowing through the R1, and I2 is current flowing through the R2. Because the path of IS and I1 and I2 is the same things. So that means IS is same with I1 and I2. Then we need to check the voltage and the power. So to get a voltage, we should use what? The Ohm's law. So V is IR. So we define the direction of the V1 here in this way. The current go to here and direction of the plus here. So what is that? This is the active convention. But in this case, the current go here to the plus, that means passive convention. Anyway, you should get the I1 and I2 and V1, V2 in this direction. So anyway, IS is 50 milliamps. That means 0.05 amps. And R1 is 8. And R2 is 16. Then to get the V1, at first we need to check the V1. The V1 is, what is that? I1 R1. When you use the passive convention, but in this direction, it's not passive. This is active convention. Then we can choose another voltage here. What is that? We define this plus minus V1 prime. Then V1 prime is specified this way. So, and V1 prime is minus V1. So what is I1? I1 is 0.05 and R1 is 8. That means 0.4 volt. Therefore, V1 is minus V1 prime is minus 0.4 volt. Then in the case of R2, it's very simple because this conversion is passive conversion. So V2 is I2R. So what is that? I2 is the same with here, 0.05, and R is 16, is 0.8 volt. Sorry. Then we can choose we can calculate the power again. Is P1 is V1 I1. P1 is observed by the resistor. R1, the V is, what is that? Minus 0.4, and current is 0.05. That means 0.02 watt minus. Because this convention is active convention, so what is the meaning of that? 0.02 watt is observed. In the case of P2, is power observed by the resistor R2. So V2 is I2. V2 was 0.8. I2 is same is 0.05. So 0.04 watt. So that means because this is a passive convention, and this is a positive value means 0.04 watt is observed. This is the last page of this video clip. So there are many problems about this chapter 2.4. So I recommend you to solve the problems in your problem set, and especially if you're not familiar with active commission and passive commission, then you need to do by yourself and understand why is different. The important thing is register observe the power. That is good. That is important things.